Okay, today we move on to the second part of section 4 on polynomials. Previously we added and subtracted them, and today we're going to multiply polynomials. We're also going to mention some formulas for some special products that will help us save some time in the long run. Just a quick reminder before we get started, exponents do not change when you add or subtract. So for instance, I have 2x plus 3x, and that's equal to 5x. There was no exponent that changed. Whereas if I have 2x times 3x, that's equal to 6x to the second. Exponents do change when multiplying and also when dividing. We'll see in the next section. Alright, in the first example here we have a binomial times a binomial. And I'm going to show you two different ways to do this because perhaps you learned one or the other. The first way is just really utilizing the distributive property, and you may remember it as the FOIL method. And so what we do here is we take both of the parts of the first set, the first binomial, the 2x is going to be given to both the 4x and the 8, and then also the negative 3 will be given to the 4x and the 8. And if you're considering this like FOIL, remember FOIL is the first terms we multiply together, the outside terms, just like the arrows we drew, the inside terms, and the last terms. And so that's exactly what distributing twice is. And so when we apply this, we get 2x times 4x, which is 8x to the second, and then 2x times 8, which gives us positive 16x, and then we move to the inside terms, negative 3 times 4x, which gives us negative 12x, and then a negative 8 times negative 3 times a positive 8, our last terms, to give us negative 24. And once we're done with all that multiplication, we combine any like terms that we may have, and then we notice that we have a 16x and a negative 12x. And remember, when combining like terms, the exponents stay the same, so our final answer is going to be 8x squared. Then we put these two together, which gives us 4x, and then we have the minus 24. Our final answer is this trinomial. Now, the other method for multiplying polynomials is known as the box method, which you may have learned. And I like the box method because it just helps keep things organized, and also when we get to factoring, it makes factoring a whole lot easier if you use the box. And so to use the box method, we put one binomial along the top, and we're using a 2 by 2 box because we have a binomial times a binomial, and you place the other binomial along the side. Now, it doesn't matter which one you put on the top and which one you put on the side, as long as you keep the terms together. So I need the 2x and the minus 3 on the same side, and I need to keep those in the same order as they appear in the problem. Okay, so now we're going to multiply these together to fill our box up. So I do the first one just like I would a multiplication chart or a Punnett square. I'm going to do 4x times 2x, and that gives me 8x squared. The next term I'm going to find is the 4x times the negative 3, which gives me negative 12x. Next, I'll do the 2x times the positive 8, which gives me positive 16x. And finally, for the last square, I'm going to do the positive 8 times the negative 3 for a negative 24x. Okay, so now that our box is full, we're just going to see if we have any like terms to combine. And you should notice right away that along the diagonal, we have two terms that we can put together. And remember, we're finished multiplying, so to combine these terms, we're going to add. And so to write our final answer down here, we write the first box, which is 8x squared. We write our two terms that we're going to combine, which gives us 4x positive. And then our last term here, our constant, is negative 24. And so, because this is the same problem as we just worked on the previous slide, we do come up with the same answer, just a different way of getting that answer. Okay, our next example here is a binomial times a trinomial. And you can also do this one of two ways. The first one we're going to do is just distributing. So we're going to take the 5x and we're going to give it to everything in the second parentheses. And then we're also going to take the negative 3 and give it to everything in that second group of parentheses. So we're just distributing twice, really. So the first one, 5x times 2x squared, would give us 10x to the third. Our next term, 5x times 4x, would give us 20x squared. And then for the last distributing of the 5x, we do 5x times a positive 1, which would give us positive 5x. And then we begin to distribute the negative 3. Negative 3 times positive 2x squared gives us a negative 6x squared. Next we have negative 3 times positive 4x, which gives us negative 12x. And finally we have negative 3 times positive 1, which gives us negative 3. Now once we've taken care of that distribution, and which is the multiplication part, we combine like terms. And so the first term I'm looking at here is the 10x to the third, and I notice that no other term is like it, so I'm just going to take that one and write it down. And so next I go to my squared terms. I have a positive 20x squared and a negative 6x squared. So 20 plus negative 6 would give me a positive 14x squared. And then I go to my x term. I have a positive 5x and a negative 12x, and together that gives me negative 7x. And then we just write down our constant here, because there is no other constant to go with it, negative 3. And so my final answer is this polynomial. Now, that same binomial multiplied by that same trinomial, we can get the product of those using the box method, just like we did with the binomial times the binomial a little while ago. The box is just a little bit bigger. For a binomial times a trinomial, we need a 2 by 3 box. And so we have to put along the left-hand side here the 5x minus 3. Along the top, we'll put our 2x squared, positive 4x, and positive 1. And remember, to fill the box up, we're going to be doing multiplication, so exponents are going to change. Alright, so to start off here, we're going to do the 5x times the 2x squared and put in this square here. And 5x times 2x squared gives us 10x to the third. Next, we'll do 5x times 4x, and we get 20x to the second. And next on the top row, we will do 5x times 1, and we get 5x, which completes our top row. And so we move on to the bottom row. Negative 3 times positive 2x squared gives us a negative 6x to the second. A negative 3 times a positive 4x gives us negative 12x. And then finally, negative 3 times positive 1 will give us negative 3. Now again, we look for our like terms. And what I like about the box method again is that normally our like terms are along the diagonal from each other. And so our first set of like terms are the 20x squared and the negative 6x squared that go together. And then our second set of like terms are the 5x and the negative 12x that go together. And remember, I'm going to be adding both of these groups together for our like terms. And so to write our final answer over here to the right, I'm going to begin with my highest exponent, which is cubed. And so we write 10x to the third. Then I'm going to combine these two terms, 20 and negative 6, which makes positive 14x to the second. Next, I'm going to combine, sorry about that. Next I'm going to combine the negative 12x and the positive 5x, and that's going to give us negative 7x. And then finally we write our constant, negative 3. And so just as the previous slide, we got that polynomial. This is the same polynomial multiplied. We multiplied the same to get the same product, just a different method. So whichever method you choose to use is up to you. I just wanted to give you the option of doing either one. Okay, now in this next example, I'm going to show you both ways again. The only difference is that we have two variables where we've only had one variable previously. We have x's and y's. So I just wanted you to have something to look back on if you come across this in any assignment. And so for this first method, which is just distributing, I'm going to give each term in the first parentheses to every term in the second parentheses. So we'll start with the xy is going to be given to this, to x squared, to the negative xy, and to the y squared. So beginning that way, we have xy times 2x squared, and that gives us 2x to the third y. And then we have xy times negative xy, and that's going to give us negative x squared, y squared. And finally we have xy times y squared, which is going to give us positive xy to the second. And so next we're going to be giving the negative 2 to all three of these terms in the second parentheses. So first, negative 2 to positive 2x squared. That's going to give us negative 4x to the second. Then negative 2 to the negative xy. It's going to give us positive 2xy. And finally, negative 2 to positive y squared is going to give us negative 2y squared. And just as before, we're going to be looking for like terms, keeping in mind that like terms have to have the same letter, the same variable, and the same exponents. So looking first at the 2x cubed y, I notice that none of the other terms have an x cubed and a y. So I'm just going to bring that term down, 2x cubed y. So next I look for x squared y squared. And I notice that none of the other terms have an x squared y squared. So I'm going to write minus x squared y squared. Next, I'm looking for xy squared. And again, none of the terms have an xy squared. And if I continue looking for like terms, I'm going to notice that the last three are not like terms either. So they're just going to become part of my answer. And so we have a fairly long trinomial for our answer. Now taking that same problem and applying the box method, I'm going to have xy minus 2 along the side. And along the top, I'm going to have 2x squared, negative xy, positive y squared. And remember to fill the box. I'm going to be performing multiplication. So first here I have xy times 2x squared, and that's going to give me 2x cubed y. Next I have xy times negative xy, and that's negative x squared y squared. And finally on the top row I have negative xy times positive y squared, and that's x y to the third. Moving to the bottom row, negative 2 times positive 2x squared, and that's going to give me negative 4x squared. Next, I have negative 2 times negative xy, and that's negative 2xy. And finally, in the last box, I have negative 2 times positive y squared, which is negative 2y squared. Now previously, when we use this box, along the diagonals we will have like terms. You'll notice that in this case that is not true, and that's because of the two variables being used. So just be careful. Sometimes there will be and sometimes they won't be. Just look closely. And so if we write our whole answer down, it's going to be 2x cubed y minus x squared y squared plus xy cubed, and I've ran out of room, minus 4x squared minus 2xy minus 2y squared. Now, given that you have enough room, this answer would be all on one line. Now these last few slides are just some examples of if you recognize this situation, I know that I can quickly get to the answer without distributing or the box if I apply this formula. So given this first example, 2n minus 4 times 2n plus 4, I know that I can take the first terms, multiply them together, and that gives me 4n to the second. And then take the last terms, multiply them together, which gives me negative 16, and that's my answer without having to go through all the distribution or the box method. Now, if you don't remember this, that's okay, because you can always get to the answer using the box method or distribution. Now, along the same lines as the previous slide, if I notice that I have perfect squares, I can apply one of these formulas here, depending on if it's a sum or if it's a difference. And so for this first sum, the formula says take the first term and square it. So I'm going to take the 3x and I'm going to square it, which is going to give me 9x squared. Then the formula says do 2 times the second term and the first term together. So I'm going to do 2 times 4 times 3x, and that's going to give me 24x. And then the formula states take the last term, the a, and square it, and so that would be my 4, and 4 squared is 16, so plus 16. And so I did not have to use the box or distribution to come up with this answer. And so if I recognize this, then I can apply the formula that goes with it. Now in the same way, if I have a difference, then I can apply this bottom formula, which says take the first term and square it. So my first term is x, so I'm just going to have x squared. Then the formula states do minus 2 times a times x, so minus 2 times the last term times the first term, so minus 2 times 3 times x, so in our case that's going to be negative 6x, and then the formula states take the last term and square it, so negative 3 times a negative 3 would give us positive 9. And again, I've taken a shortcut and not had to do all the steps. But again, if you forget these formulas, that's okay, because you can always come up with the solution with the box or with distribution. And here at the end, I'm a big fan of the Transformer movies, and because it takes me back to my childhood when there was actually a cartoon about the Transformers, when they had good cartoons back in the day, and so I liked this cartoon.